So I found this really tough looking question online that I thought might be good practice. A pump energy storage station has a power generation capacity of 3 gigawatts. The height difference h of the system is 380 meters. Assume the system has an overall energy efficiency of 80%. What volume of water from the upper reservoir would need to flow in a 30-minute period if a city is being provided with 3 gigawatts of power for this time? There are a lot of words here and it's hard to understand, so I made this diagram to show you what's going on. So the water is stored in this upper reservoir here, and the energy stored is potential energy because it is up at h height. And then when the energy is being used, it comes down this tube, goes through this turbine here, powers the motor, then goes down into the lower reservoir. So since we have h, we know this is a potential energy problem. So we should start by doing the potential energy formula. EP equals M, G, and H. So you might have noticed that we didn't get an energy, we got a power value instead. So that means we need to convert this power we have into energy. So the formula for power is P equals P equals work over time. So we can rearrange that into we need work. So work is the same as energy in this case. Work is P times time. So here we can simplify this into PT equals MGH. And we have 3 gigawatts times 30 minutes. But we have to convert this 30 minutes into seconds first. So let's just do that. 30 min times 60 seconds per min equals 30 times 60, which is 1,800 seconds. So gigawatts times 1,800 seconds equals MGH. And now we get 3 times 1,800 gives us 5,400 gigajoules. We'll convert this into joules though, because that'll make things easier. So to do that, we just multiply by a billion. So change this into scientific notation as well. 10 exponent 9 plus 1, 2, 3. That's 10 exponent 12 joules equals MGH. So now that we have the energy, we can, oh right, I forgot, we need to consider efficiency as well. So we have the energy, and then to find the energy we have right here is the energy is 80% of the potential energy we have, because the efficiency is 80%. So that means there is another, we need to multiply what we have here by 100% over 80% to get back that energy we're missing from the efficiency. So after we multiply it by 100 divided by 80, we get 6.75 times 10 exponent 12 joules equals mgh. So we're done on this side for now. Now we can focus on the other side. So we are given height, we know gravity, but we don't have mass. So that's what we're going to be solving for. So 9.81 meters per second squared times the height, which was it 380 meters over here. That gives us 9.81 times 380, 3,727.8. We'll just change that into scientific notation because that'll make our calculations easier. So it's 3.2473. We'll just round it up here for now. Meters squared per second squared times the mass. So now all we have to do is divide this side by 3.73. Oh, my bad, I forgot the scientific notation. Times 10 cubed meters squared per second squared. Okay, now we just divide both sides by this to solve for mass. So mass equals 6.75 divided by 3.73 equals 1.81 times, we subtract the exponents, so 12 minus 3 times 10 exponent 9 kg. Now if we look back at the question, it is asking for what volume of water. So you might not know this, but there's something called a density formula. D equals mass over volume. This is what it's called. So D, there's a specific D for water, a density. It's not given, which I think it should, so we have to look that up. But we have the mass, so we can switch this around. So volume equals mass divided by density. I googled it. The density of water is 1 kilogram per liter if we're looking for liters. So we take our mass, we take V equals mass divided by density equals 1.81 times 10 exponent 9 kg over density, which is 1 kg per liter. So we can cross out these kg. Because we're dividing again, the liter goes up here into the numerator, and we get 1.81 times 10 exponent 9 liters, or we can write that as 1.81 gigaliters. And that is our final answer. I found this question on Khan Academy, and I think that's good practice. If you need some more practice, I'll leave the link in the description, and thanks for watching.